Hi everyone, I'm Dana and welcome back to Inverter Always. In today's video, we're going to be discussing some important things to check, verify, look out for before you start up a VRV system. In the last video, we discussed some tips and tricks during the installation process and things to look out for to try to make your installation go as smoothly as possible. And in today's video, we're getting closer to doing an actual startup, but I wanted to give you just a few things that could help you along the way to make sure that as you're getting ready to power up the equipment to do your startup, your commissioning procedures, if you will, there are a few pre-commissioning steps that you need to make sure you do. So I hope you guys enjoyed today's video. If you do, please click the like button below. It really helps out my channel. And if you enjoy this content and haven't already, please consider subscribing. Also, before we jump into today's video, you guys, just a quick shout out to the newest channel member. And I hope I get your name correctly, but it is Uma. Thank you so much, Uma, for your member subscription. It's greatly appreciated. All of you guys, all of you members, thank you very much for continuing to support my channel as we grow. So if you guys enjoy this video, share it with your friends. Hope you guys learned something. All right, let's jump right in. Now, you guys, one of the most important things to consider when it comes to the lifespan and performance and the efficiency of a heat pump system, especially that of an inverter-driven VRF system in this case, your most important component that you need to make sure that gets installed correctly is the refrigerant piping. If corners get cut, if certain things don't get done properly, and you have a dirty refrigerant system, you get contaminants in the system, moisture in the system, you're going to decrease the performance. You're going to decrease the lifespan of that system. It's easy to fix things like wiring errors later on, but the last thing you want to have to do is cut back into the refrigerant piping after you've started up the equipment and had a failure of a component, whether it's a valve, whether it is a restriction in the line set, whether it's a failed compressor or a clogged strainer, whatever have you. You don't want to have to cut back into the refrigerant system. So as we talk about some of these things today that are going to help make the commissioning go as smooth as possible, these pre-startup bullet points, things to consider, they're largely going to be focused on the refrigerant side of the equipment. There's a few other things we're going to talk about in today's video, but I just can't stress enough as we're going through these bullet points to really consider the amount of time, which is money, that it would take to cut into the system and repair the system. We don't want to cut into the refrigerant piping. So as we're going through these things, take that into consideration. We want to do our job correctly the first time, even if it takes a little bit longer up front, because then we're not going to have to come back later to fix it. So the first thing we're going to talk about today is your pressure test. After you've installed all the refrigerant piping and hopefully measured your lengths of each section of piping along the way, we've talked about this in a future video, and I'll bring it up here shortly as well. We need to do a pressure test. And the pressure test is super important. It might seem like it's a no-brainer, but this gets skipped a lot. This gets done incorrectly too often because people don't necessarily know everything that's involved in the pressure test. It's not just throw it up to 300 PSI for 20 minutes and look for a big leak. There's more involved to it. On Daikin VRV systems specifically, Daikin wants a 550 PSI pressure test in the North American market. And I'm not going to pretend to know what that is overseas as a conversion factor. I'll throw it up on screen here so you guys can see that. And I'll just do that in editing, but 550 PSI. So if you guys do not have a high pressure regulator hooked up to your nitrogen tank, you're not going to be able to get there. When guys have problems in the field, they call up and I ask, what was your pressure test? And they say, oh, I got it up to about 330 PSI. That's not going to cut it. That's not going to check for some of the leak points that you might have in the system. The system is going to operate above that pressure. So you need a high pressure regulator. It's extremely important that you get that pressure test up to 550 PSI. Now, the next thing to consider is if you have a particular type of indoor unit, specifically, this is going to be more common in the North American market, but the FXTQ multi-position air handler or the CXTQ A-coil that gets paired with the communicating gas furnaces. And I don't believe these are available overseas, although you guys have a huge book of product we don't have in North America, so you might have something similar to this already. But those particular coils are built a little bit differently. Therefore, anytime you have one of those installed on the system, you only pressure test the system to 450 PSI, but nonetheless, you still need a high pressure regulator to be able to get up to that pressure. Now, Once you get to that pressure, whether it's 450 psi because you have a bunch of FXTQs installed, or it's 550 psi because you don't have any of those types of units installed, you need to hold the pressure for at least 24 hours. I know what you're going to say. I know what you're thinking. I get this argument all the time. We don't need to pressure test for that long. We'll be able to find leaks before that. Plus, when we do our evacuation, we'll be able to check if there's a leak at that point. And albeit that might be somewhat true, we're not just doing the pressure test to check for a leak. The second thing we're doing with the pressure test is we're checking the integrity of the components. And I'm going to give you a couple of examples here to more explain what I'm talking about. When you do your pressure test, let's say that you only do a pressure test to 300 psi. And maybe that's because you just didn't know any better. Maybe you didn't read the manual. Maybe you don't have a high pressure regulator. Whatever the circumstances, you only pressure test the system to 300 psi and it held. Maybe you only held for 1 hour. You went and did your evacuation. You pulled a good vacuum and then you put refrigerant into the system and started up the system. And within a matter of days, hours, maybe it took a week. Nonetheless, at some point you found a leak. There was a leak in the system. The refrigerant completely leaked out of the system. Customer calls you back. You have to go back. You have to now find the leak. Then you have to repair the leak. Then you have to open up all the valves in the system. If it's a VRV system, there's a process for doing this. And then you have to pull the system back down. I mean, there's a much bigger process involved. And if all your refrigerant lines are concealed at this point, maybe in the walls, maybe in the ceilings, there's going to be a lot more time. There's going to be a lot more money involved to find and correct that error. Whereas if you had previously just done the proper pressure test and let it sit for 24 hours, there's a chance you may have found it during that point. Some of the more common issues that we find in our market are the line sets themselves. We sell and install tons of different manufacturers of line sets. So there's line sets coming in from all over the world, and some of them are manufactured better than others. I've actually seen this happen where we put the system on a pressure test, and maybe 45 minutes in, maybe 3 hours in, all of a sudden we spring a leak. And the leak is actually in the line set itself, and it's from a I call it a fracture in the refrigerant lines, but it basically looks like a leak forms right on the roll. So maybe it just didn't get rolled properly from the manufacturer of whoever did the tubing. I don't know, but that is a weak, that is a poor integrity component. So your line set has poor integrity in that particular case. Doing a pressure test for an extended period of time is going to give the system that chance to reveal those weak spots. Another situation that came up more recently is in one of the FXTQ air handlers, there was actually a leak that did not get caught during the pressure test. When the system was fired up, the system started to operate. After that extended period at a high pressure, the leak formed. There was a weak spot in one of the bends within the coil, and the system dumped its charge. If in this particular case we had done a proper pressure test for a minimum of 24 hours, there's a more likely chance that we could have found that leak during the pressure test, because that weak component under the long period of high pressure would have leaked at that point rather than later. And if it leaks when you're just on your initial pressure test, the entire system is still exposed. The entire system is still accessible. And so the idea here is we want to find weak components. We want to find all of our leaks during the initial pressure test rather than later, because we don't want to have to come back. We don't want to have to dig into insulation and dig into the walls or the ceilings or concealed spaces where we don't have good access to try to search for leaks. Think of an application where you have a school. You fire up a system and then school is in session. You can't just get up into the ceiling to look for leaks. And so if you're doing all of this during construction when school is not in session, you have access to find the leaks faster. So it's all about how much time is it going to take now if we find the leak versus later if we have to come back to find and then fix the leak. So always do a pressure test for at least 24 hours. And we're not just checking for leaks, we're also checking for integrity within each of the components. Now, once you guys pass the pressure test, whether you did a 24-hour pressure test or a 48-hour pressure test, depending on your application, some applications, systems will sit on pressure for weeks, months, because usually the guys running all the refrigeration tubing, the refrigeration copper, they're done with that portion of the install before everything else gets done. Condensate, ductwork, electrical, a lot of that stuff gets done later. And so on the commercial projects that I'm involved with, a lot of times the systems will sit on pressure for weeks at a time. It's usually in the residential world where getting that 24 hours is more of a challenge, but I digress. However you get to this point, at some point you're going to be done doing your pressure test. You're going to pass the pressure test. You're going to find there are no leaks in the system and the integrity of all the components seem good. Now you need to do an evacuation. One of the biggest, I should say, issues that I find during a startup or later on when a system has failed is there's moisture in the refrigerant lines. And sometimes this happens because whoever was doing the evacuation turned on a vacuum pump and then just let it sit there overnight or over the weekend. On larger systems, it takes longer to pull the refrigeration lines into a vacuum. And so guys will, on a Friday afternoon, turn on the vacuum pump, go home. On Monday, they come back. Oh, look, I've got 200 microns. I must be good. Let's add refrigerant in and let's start this bad boy up. And unfortunately, that can cause a problem. For starters, when you pull vacuum on refrigerant lines, you do have a chance. It's not guaranteed this is always going to happen, but you do increase the risk for any moisture inside the lines to freeze inside the lines. And you can't pull that out under a vacuum. So your vacuum on your micron gauge may look good. It might say 200 microns. However, there is still moisture inside the lines. It's just frozen. And so what we recommend doing is a triple evacuation. And in the process of doing a triple evacuation, you basically pull your system into a vacuum. And this might be 1,500 microns. This might be 1,000 microns. The number specifically is not as important as doing the process of a triple evacuation. So whatever number you start with, let's just say you start with 1,200 microns. After you get the vacuum down to 1,200 microns, now you need to break that vacuum with a little bit of dry nitrogen. When you do this, you're not doing another pressure test. You're just breaking the vacuum past atmospheric pressure. So that might be 5 psi, 10 psi. It's just enough nitrogen to break the vacuum. And then you're going to pull another vacuum. But this time when you pull your vacuum, you're going to pull the system down a little bit deeper. Maybe this time you pull the system down to, say, 750 microns or 700 microns. Again, the number itself isn't as important as the process that we're following here. You're going to pull the system down a second time. So let's say the second time you pull it down to 750 microns. Okay, great. After a few minutes of holding that, you're going to break the vacuum once again with dry nitrogen. And again, you're just going to break it to about 5 psi, 10 psi. You're not doing another pressure test. You're just breaking the vacuum past atmospheric pressure. Doing this multiple times allows any moisture that has frozen inside the lines to go back to a gaseous state so that when we do our next vacuum, we can pull that moisture out. Now you're going to do your final evacuation, and this time you want to pull the system, at least on Daikin products, down below 500 microns. Now here's where another problem happens, and this is very, very often that I see this problem happen, is guys will pull vacuums down to 400 microns, 300 microns, you name it. It gets below 500 microns, but when you get to that level, you're supposed to isolate the vacuum pump off the system. Isolate your hoses and your manifold off the system. So typically what I recommend doing is putting a Schrader core removal tool on the service port. Then on the T of the Schrader core removal tool, you can put your digital micron gauge. So that way, when you get down to the vacuum that you want, you can close the isolation valve to eliminate the hoses and the gauges and your vacuum pump completely off your refrigerant lines. So that way you're testing. Sorry if you heard the kids, it's the weekend and these things happen. But now you are only testing the actual micron level of the field piping, and that's what we want to do. What I see happen, and this is an issue a lot, is guys will pull it down to 300 microns, close that valve, and then they'll sit there and they'll wait their allotted test time. Now the test time is supposed to be a 1-hour standing vacuum test where you can't exceed 500 microns. So guys will stand there and they'll watch the vacuum. It'll go from, say, 400 microns to 415 to 430 to 450 to 470 to 490 to 495. Oh, there's my 1-hour timer. I'm done. It didn't get past 500. I'm good to go. And albeit yes, you are good to go. It didn't get past 500. If you look at that 1 hour test and you look at the decay rate of your vacuum was decaying very quickly. And if you would have waited just a couple more minutes, you would have gone past 500. Anytime you're looking at your digital micron gauge and your vacuum is decaying, where your vacuum is rising, it's going from 400 to 500 quickly or 300 to 500 quickly, you should do one more purge with dry nitrogen, break that vacuum, and pull it down a fourth time. When you pull your vacuum down to whatever that level is, you're going to start your test at, say it's 350 microns. Within that 1 hour time frame, you shouldn't be decaying all the way up to 500. It should find a point that where it stabilizes, and maybe it stabilizes at 375, maybe it stabilizes at 380. But you should find a point where it basically starts to stop rising. It finds where it's actually at, and then it sits there. So for example, when I did my house, I pulled my house down 4 times to 400 microns. And when I did my test, I actually did my test for 3 hours because I was busy running electrical and doing other things. But it only rose to 410 microns in that 3 hour time span. So I had a very, very, very good vacuum on my system. There are accessories out there and tools, different gauges you can get to help with this. I'm not sponsored or anything in this video, but the tools I prefer to use for my micron gauge is the BlueVac Pro, because the reason this is really important is it will graph your entire test. I don't have any pictures to show you or anything, but if you go to Google and just type in a BlueVac Pro, it's a little micron gauge. They have a stick version and they have the round version, but it's Bluetooth. It'll go to your phone or tablet where you can see the graph. You can actually tell it in the software, in the app, you want to target a 300 micron start test and your decay rate is up to 500. And it will calculate within minutes what the decay rate actually is, if you pass or fail, and then you can email that report to yourself or to your office. So now you have that report on file. If there's ever an issue later, you can show, hey, here's the triple evacuation that I did, following all of the procedures. I had a very good vacuum, so it's not on me. The issues came from somewhere else. A very neat tool that I like to use. I like to file everything and keep everything organized. So if you guys want to pick that up or check it out, again, not sponsored, just my recommendation. So you guys have completed the triple evacuation process. Good job. Now we need to calculate how much refrigerant we need to add to the system. This gets missed all the time, especially on VRVS or VRV life systems. People don't realize that you have to add refrigerant on every single install. There is refrigerant in every single outdoor unit, but there isn't enough for X number of feet or X number of meters. So it doesn't matter if you install 10 feet, the bare minimum amount of line set on, say, a VRVS 3-ton outdoor unit, you still have to add refrigerant. And so how much refrigerant do you need to add? Well, the amount that you're going to add is going to change on every single system. And I'm not going to go through every single procedure. I'm going to give you a couple of examples in today's video, but you need to make sure you're opening up the outdoor unit installation manual, because in that book, there's going to be a page and a chart where it shows you how to go through and calculate the amount of refrigerant that you need to add to that particular type of system. For example, on a VRVS, you're going to add based on the length of your liquid line set. So if I have, let's just say, a 1-to-1 3-ton air handler, 3-ton outdoor unit with, say, a 100-foot line set, and that is a 3/8 liquid line, then it's 3/8 length, 100 feet times 0.036 pounds. So you end up getting 3.6 pounds that you need to add. That's an easy math for this particular example, but that's the only thing you need to do in that particular case. When you move to a VRV heat recovery system, things change. You have to add up all the different lengths of refrigerant lines. So outdoor unit to your RefNet branch, if you have a RefNet branch, from the RefNet branch to each of the branch boxes, from each of the branch box ports to the indoor unit, and all those liquid lines are going to have different sizes. So you're going to do the same thing we just did, but for each of those sizes, there's going to be a different amount that you add per foot or per meter, and you're going to need to add all that up. But you don't stop there. On heat recovery systems, you then need to add more refrigerant based on the outdoor unit size, branch box size, quantity of branch boxes, connected ratio versus your total line set length from outdoor to furthest indoor unit. And in some cases, depending on the indoor unit style that you have installed, sometimes you need to add refrigerant for that as well. So there is a process involved. The important thing to remember, though, is every process is going to be different. So you need to open up the installation manual of the outdoor unit to do these calculations. You can't just turn on the system, let it run, and try to add refrigerant to the system based on subcool calculations or superheat calculations. This is not a traditional system where you turn on the compressor and just go. The compressor is going to have many different speeds, and you don't know when you're operating the system what speed that compressor is running at. So you can't properly calculate subcooling without many more other factors and variables within that equation. So the only way to get started with these pieces of equipment is to calculate the refrigerant charge. Later on down the road, if your system isn't performing properly and you need to tweak the charge just a little bit, there are ways to do that with subcooling. But you're not doing that for your initial startup. Now that brings us to the next point. I'm going to give you guys a link in the corner now for you guys to check out a video I did very recently where I went through and actually showed you the importance of measuring out all of your lines as you go through the install, because all these sizes could change during the install based on the lengths, based on how you route them in the field compared to how the original refrigerant piping schematic was printed. And so make sure you check out that video, because I'm giving you way more information in that video as it relates to getting to this point where we're calculating the refrigerant charge. You need to be measuring those lengths as you go and writing them down so that you don't get done with the job, have all the line sets completely insulated in the walls and sealed up behind sheetrock, and now you need to go walk the hallways and try to figure out, well, shoot, how long was that line set? I'm just going to measure. Yeah, it was about 35 feet. If you do that for 85 indoor units on 4 different heat recovery systems, you're probably not going to be super accurate, which means your charge is not going to be accurate, which means you're going to have performance problems. So make sure you're measuring those lines as you go, because you're going to need them when you get to this step to add refrigerant. Now, this next one is very easy, but it gets missed all the time. That's why I'm talking to you guys about it. Before you power up the equipment, when you are adding the refrigerant at the outdoor unit, you need to look down at the compressor, because every compressor is going to be shipped with a shipping bracket. And there are 2 different types of brackets. I think I have a picture. If I do have a picture, I'll go ahead and I'll show you that now. If you guys don't see a picture, it's because I couldn't find it. I apologize. But there are 2 different bracket styles. There's a little yellowish orange one that ships on VRV3 heat recovery and heat pump systems and earlier generation product, and VRV-S and VRV Life single phase heat pumps. And then on VRV-X, Mirion, and later generation systems, you're going to have a more flat silver gray metal bracket. Regardless of the style, you need to look under the compressor blanket for a bracket of some kind and remove that bracket. Because if you do not remove that bracket when you operate the compressor, it's going to sound like crap. It's going to sound very loud, and that could damage the compressor. We don't want damage to the compressor, so make sure you remove that bracket. So I think at this point we're ready to power up the system and do our startup, check our performance, but we can't do it yet. So before we actually power up all of the equipment, we need to warm up the oil in the compressor. So the day before or the night before that you're doing your startup, go ahead and power up the outdoor units. So that way, when you get there the next morning, you're ready for startup. The outdoor units have warm oil in the system and they're ready to go as well. Now there's a whole startup procedure to go through, which I'm going to give you that startup procedure in the next video. So make sure you keep your eyes out for that. Make sure you turn on the notification bell so that way you can see as soon as I post that video. But you want to make sure that you have power to the outdoor units for a minimum of 6 hours before you try to operate the equipment. And the last thing we're going to talk about today is your dip switches. If you have a heat recovery system, specifically a VRV4 or newer generation heat recovery system, you need to set dip switches on the branch boxes For any ports that are unused, capped off basically, maybe reserved for future use, or just extra ports in general. Also, dip switches for twinning ports together for larger capacity connections. And there's a few other things that you may need for the dip switches for. But most of the time it's for those two things. You need to make sure that you set those dip switches before you power up the entire system to do your test operation. You will not pass the test operation if the outdoor unit sees a different number of ports on the board being used than the actual number of indoor units wired to those port terminals. So they have to match. I actually did a video on this, so I'm not going to go into any more detail in this video. I'll put a link in the corner so you can check out that video where I go into great detail and walk you through step by step how to set the dip switches, when to set the dip switches, which dip switches to set, etc., etc. So make sure you check that video out if you have a heat recovery system, and that will save you time so that you don't fail the test. Every time you fail the test, you have to power down the entire system, go fix the problem, then power the system back up, then wait for up to 15 minutes for the system to initialize before you can then again start the test. This whole entire series, the whole point of me telling you all of these things to look out for is to save you time throughout this entire construction process. I want things to go smoothly for you guys so you don't run into these problems, so that you don't have these headaches. So you guys, that is it for today. Hope you guys enjoyed today's video. If you have any questions, of course, put them in the comments below. I read all of your guys' comments. I do give priority to my responses to channel members. So if you guys are not already channel members and you enjoy and appreciate this content, if this content helps you out, feel free to become a member. If you guys enjoyed today's video, please click the like button below. It really helps out my channel, especially as we're still growing. If you guys haven't already, please consider subscribing. All right, you guys enjoy the rest of your weekend. Thank you so much for watching Inverter Always. I'll see you next time. Bye.